you get into organic chemistry, you're dealing with a lot more atoms. And so the way I had you draw it, you could start from the left and then just keep adding atoms as you go right. sp3 is by far the most common hybridization scheme in organic chemistry. And so the way you can do it, let's say I wanted to build up a more complex structure, sp3. And so if I do 2 in the plane going this way, then I can draw one like this, and then draw 2 in the plane like this. And therefore, if I have another atom, I'll just add it here, and it's going to be in the plane. And then, well, I'll draw 2 in the plane this way. This is the way you start drawing these. And so A, B, C, D, and then E, and then F. And so it's easy to add more. And what you do is when you get 2 in the plane like this, then 1 sticks out, 1 goes in. 1 sticks out, 1 goes in. 1 sticks out, 1 goes in. 1 sticks out, oops. 1 goes in.
Is that why they do that with carbon bonds? They're drawn like that?
Right, and so in organic chemistry, this is it. In organic chemistry, do you know what this molecule is?
Carbon.
That's ethane. This, do you know what that is? Propane. Butane, pentane, hexane, heptane, etc. If you want to add more, you just keep drawing more zigzags, and then if you're doing valence bond analysis, you want to make sure the orbitals line up this way. 2 in the plane. 2 in the plane. This. 2 in the plane, and that means there's going to be 1 sticking out and 1 going in. If these are all sp3.
So would it be helpful to put the lone pair out of the plane?
Yeah, sometimes it's helpful to put the lone pair out of the plane so you can draw this zigzag kind of arrangement of atoms. And so in organic chemistry, it's like this. Do you see it? Zigzag. It zigzags because they just flatten it out. Obviously, there's free rotation. And since there's free rotation about the bonds, this whole thing can rotate and flip out of the plane. But this is called a conformation. You just flatten it out to make your drawing easier. And so it looks like, you know, people are getting stuck. You shouldn't get stuck. What you should do is you should have it memorized. If it's sp3, can you draw the sp3 set of orbitals? If not, you have to have that memorized. And then can you draw it the same way each time? Well, the same way if this is just the starting atom. But once I draw this, you know, the starting atom, then the others are going to have to go different ways. And so the lone pair, where should I put the lone pair? Well, it depends on where I want to put the bonds. And so I look at this, I have 3 bonds, and then I want the H, I have the H's. And so what I'm going to do is, I'm going to put the lone pair in the back here. So I got 1 lone pair and then 3 bonds. 1, 2, 3. Well, sp3. Sometimes it helps to put the lone pair back there, that way you don't have to try to draw bonds back here. Which is a pain. And so you should be able to get this. I mean, if it's sp3, just memorize it. And so the way I drew it like this, because I want to, we'll call this A, B, C. And so I'll put oxygen A here. I'm going to put oxygen A here because there are no more bonds here. And so oxygen A, what's the hybridization on oxygen A? sp3. And so this one sticks out, but you know, it's too much of a pain to do that. So what we'll do is we'll just put 2 in the plane and then 2 out. And so maybe I'll put 1 going in like this, and then one in the plane here, and then one coming out like this. Does this look good? This doesn't look good because we have to visualize the tetrahedral. The tetrahedral is not too hard to visualize with if you have like pens or like this. If I have 4 pens and I try to maximize out the angles, so just spread things out as far apart as possible, then we end up with a tetrahedral arrangement here. And we have to watch out for the geometry of this, because if I bond one of these orbitals, which direction do the other 3 orbitals point? In the opposite. Let's say if I bond one of these orbitals, actually my hand is not properly configured, but if I bond any one of these, the 3 all point in the opposite direction. And so when I see this, I think, oh, this is wrong. This cannot point in the same direction. It's got to point in the opposite direction. So if I drew it like this, then it would be okay, you know. And so I bond one, and then the other 3 are like a tripod sticking out. And so this would have 3 lone pairs, 1 bond. This would be oxygen A. So just because it's on the top here doesn't mean it has to be on the top here. The reason I reserve these 2 is to put the hydrogens in the same plane. So if I look at this oxygen, it's sp3 also. And so this oxygen is sp3, so 2 in the plane, and then 1 coming out and 1 going in. These 3 are going to be pointed back like this. And so here I want the hydrogen, so we'll put these both spin down. I want the hydrogen in the plane. And so do you see I have the sulfur, oxygen, oxygen, hydrogen bond flat in the plane? It doesn't have to stay that way because this can rotate. They're 2 lone pairs. But for drawing, it's kind of nice because if I had more atoms to add to this, I could just keep going down the page. You know? I don't draw it like this. If I drew it like this, then the problem is if I want to add more atoms, I would probably go right to left. You know? So if I drew this on the right side of the page, I'd be okay. I could draw it like that. Or I could go up, you know, to the bottom. And so there's a reason for drawing it like this. The reason is so we can just extend the structure, however long it is.
So will the opposite oxygen be faced the other way?
No, all the oxygens are 109, and so this other oxygen's at 109. You know, they're all adjacent to each other. The angles tweak like this. And so this one's going to be up here, like this. I'll draw. I'm going to have to draw this. And so, how should I draw it? I want to put the hydrogen in the plane, so let's go like this, and then we'll put the hydrogen here. And then that means 1 comes out, and then 1 goes in. These will be the 2 lone pairs here. You see, so I kind of have it to now. This part of this drawing is in the plane. This is called a conformation. 1 conformation. If I twist and rotate it, it's going to result in another conformation. All right. How about H2SO4? Here's the
The last oxygen?
which one? Well, I have the 3 oxygens
Oh,
here.
no, we do.
We need to do H2SO4, which is this structure here. So. Oh no, I'm not at H2SO4 yet. I'm jumping ahead, sorry.
Do the other
We need to do
structure.
this one.
The double.
with the double bond. There. So can you work on that one? With the double bond?